This next video will probably be split up into a couple sections because it is a little lengthy, this next concept, but if you just watch these, maybe even rewatch them a couple times, then I think you'll get the understanding of what we're about to accomplish, and that is how a computer actually performs math. We've learned how it stores numbers, stores letters of the alphabet. How does a computer add 1 plus 1? And it may be surprise you how this actually works. Or how does a computer multiply 2 times 4, for example? And we're gonna learn how this process works. So it's a 3-step process. I'll give you an overview in this one, and then we'll break it down probably in further videos into each individual step. We're going to create what's called a truth table. A truth table is a table that simply tells the computer what the answer is. It may come to surprise you that the computer does not figure out what 2 times 4 is on its own. It was taught that whenever 2 is multiplied by a 4, I want it to say 8. So that kind of surprised me. We actually have to teach the computer what the answers are, and we do so using a truth table. We then turn that into an equation, and I'll explain more. It's going to be easier to explain that when I get there. And then finally, we're going to create a circuit. And the circuit is literally the diagram that says this wire connects to that transistor connects to this transistor. That's kind of a rough view of that, but an actual blueprint. If you want to think of it like this as like a blueprint for a house, or a schematic diagram, if you've ever if you've ever had to look at a schematic diagram of like a refrigerator or electronics, they make these for all kind of devices. But step 1, truth table. Step 2, equation. Step 3, circuit. So in this video, let's just cover the truth table, and we'll stop with this video after truth table. So to develop a truth table, we first have to tell the computer what math problem do we want to do. And let's say we want to be able to add 2 1-bit numbers. And I'll explain what that means here. Adding 2 1-bit numbers means I would like to be able to add only 1-bit numbers and 2 of them. So 0 and 0. 0 plus 1. 1 plus 0, which is actually a different problem, even though it's the same answer. And then 1 plus 1. Now this would not cover problems like that. Why? Because that would be a 2-bit number. I guess I didn't actually explain that. A bit equals a binary digit. So if you take the bi, get rid of the airy, get rid of the dig, you get bit. Well, I guess you get rid of the I too, or pick whichever I you want. Binary digit is a bit, which means that's a 4-bit number, that's a 6-bit number, etc. Okay, so probably didn't explain that, but if we're doing a truth table for 2 1-bit numbers, these are the only 4 math problems that it can handle. Okay, because anything else would be 2 bits. Okay, so here's how this is going to work. We're going to give each, let's just write an example of one here first so we can kind of see. We're going to call this x, and we're going to call it kind of like a variable, and we're going to call this s. I use s for sum. These letters are arbitrary, but that's just what I recommend. And you're going to label a table, and we're going to put down all the math problems that are possible with 2 bits. So we could add 0 plus 0, 0 plus 1, 1 plus 0, or 1 plus 1. Okay? There are no other possibilities. If it helps, if you want to help you kind of think of these, you can put a plus beside them. Now, here's where a lot of students sometimes have a problem, and let me recommend something. I would not get in the habit of just saying, let's say we could do 0 plus 0, we could do 1 plus 1, we could do a 1. Just don't try to come up with them in your head and remember them in any order. It is true that the order will not matter to do the problem correctly. However, it will mean that when we do 3-bit numbers and you have a table that looks like this, and you have to have 8 of these, you'll always be forgetting 1. Okay, so here's how I would try to do it. I would just count 0 to, in this case, 3. So 0, 1, 2, 3. And that's why I said it would be good to memorize those numbers, because you'll be using them here. And that way you'll know that you have not missed a combination of 1s and 0s. Again, much more difficult in the 3-bit numbers and the 4-bit numbers that we'll do to not forget one. Okay, does that kind of make sense? So let me erase all this and we'll continue. Now that we have told the computer, these are the numbers that you can add, I now need to tell the computer what the answer is. The computer does not know the answer to 0 plus 0 unless we teach it and say, that's a 0. When that happens, I want it to be 1. When that happens, I also want a 1. And I want that, actually let's do a C and an S. I forgot about the carry. That stands for carry, that stands for S. Again, it's arbitrary, but that's the letters I like to use. And in fact, let's fill that in. Okay, I almost forgot about the carry. So I'm going to go slowly and make sure this is clear. When 0 and 0 are added together, I want the computer to give me the answer 0, 0. When 0 and 1 are added together, I want the computer to give me 0, 1. When 1 plus 0 are given to the computer to add, I want the computer to tell me 0, 1. And when the computer tells me 1 plus 1, I want the computer to give me 1, 0. Hopefully that makes sense. Again, rewind that if it didn't, but that's important to understand that concept. Okay? Now, I think I said I was going to split this up, but I think I'm just going to continue and do the next step in this video. The next step is to create an equation. So this was step 1. Step 2 is an equation. And I'm just going to write it out and hopefully it'll make sense. You're going to have an equation for every output bit that you have. Okay, so these are inputs to our math problem. These are outputs. These are the values I want to work on. These are the answers. So you're going to have a C equals and an S equals. It's an equation, kind of like a chemistry equation. The way it works is you're going to look at one column at a time. So let's just look at the S for right now. Just worry about S. If there's a 0 in that column, in that row, skip it. Doesn't affect the answer. If it's a 1, you're going to write X and Y side by side. And if there is a 0, you're going to put a line over it. I know this is all seeming very, let me try a little bit higher up, confusing right now, but trust me, we're going to do this several times and you'll get the hang of it. You're going to, for each row that you have, you're going to write a plus beside it, even though you're not adding. That's going to be kind of complicated. I'm going to explain why in a moment. They use a plus. I wish there was another symbol they use, but it's a plus, but it's not addition. Here's another row. Sometimes I'll write arrows that say these are the rows we need to have. It's still X and Y, but this time the 0 is in the Y column. And that's it, because 0 we don't care about. So now let's look at this C column. And it's actually easier, because we don't care about that one, we don't care about that one, we don't care about that one, and here we have an X and a Y, but no lines over it because they're both 0s, but they're both 1s. Now let me explain what this equation means. This is a Boolean logic equation. George Boole lived about 150 years ago. He was a mathematician, and he developed this system of logic. Okay, in his system of logic, everything boiled down to a couple things. We're going to cover 3 of his logic operators. He had more, but we're going to do 3. And, or, and not. Okay? In his Boolean logic, think of these as almost like a symbol, like a math problem, like a plus or minus. You would have values like 0 and 1, or 1 and 0. And here are the rules of Boolean logic. So I guess you may write, first of all, write these down. And then, let me give you a little definition. Both sides, I should say, both sides must be true for answer to be true. Okay, so here's what that means. 0 and 0. Well, I said both sides must be true. Remember, 0 is false, 1 is true. So 0 and 1, the answer to that logically is 0. 0 and 1. The answer to that is 0 because both sides must be true. Again, if this is confusing, it's always confusing for every student, whether it's live, taught in class live, or this way. It just takes a couple times of going through this for all to make sense. 1 and 0 is also 0 because both sides must be true. So we finally have both sides the same, true. Not the same because these are the same, but it must be both true. We have a 1. Now, to simplify this, I always use this example in class, and I think it helps, hopefully. But here's how it works. Let's use, this is a system of logic. So I'm going to make a statement, and I'm going to say, I'm going to go to a soccer game. I'm going to go to a soccer game in Greenville today. Let's say the school is playing Hampton Park in Greenville. I'm going to go to Greenville if the following two conditions are true. And let's write them out. If I have money, because I got to pay to get in, that's one condition. And I have a ride. Let's say I don't have a car, so I need to get a ride. A friend, the bus, take an airplane, anything. I have to have a ride to the game. Now, let's apply this logic. And the output is whether you go to the game or not. So 0 and 0 would be kind of like saying, let me erase this real quick. So this would kind of like be saying the following. 0 is I don't have money. And 0 on the right is I don't have a ride. Okay, so let me ask you a question. If you don't have money and you don't have a ride, are you going to the game? False. I am not going to the game. Okay? I don't have money and I do have a ride. Okay, I said do because now we're kind of using this row as our example. And this one is 0 and 1. So therefore, I don't have money, but I do have a ride. Well, I'm not going to the game because I got to have both of those. False. That kind of make sense? I really hope so. If I'm not explaining this well, try watching it again. I keep repeating that this may be confusing because historically students have always struggled the first day of this and then picked it up the next day. This row, I have money. I'm just going to draw a dollar sign. I have money, but I have no ride. I have money and no ride. You could say and between all of these. I should have written that. Well, guess what? Still not going to the game. Because I can have $1 million, but if I don't have a ride, anyone willing to take me, I'm not going. Now, in the fourth row, I have money and let's just draw a little car here. Ooh. I have a car. I have a ride. That means I am going to the game. Okay, does that kind of make sense? So Boolean logic has these three operators. The first one we've talked about is and it says basically if both sides are not true, then the answer is false. Okay, and I try to use these examples of money, but they also work with just ones and zeros. Any 0 on either side of this, and the answer is going to be 0. Okay, now the next one, and let's erase all these, is or. Okay, so or. Here's how or works. Hopefully you can kind of see the logic as I go. or I'm going to draw the table first, and then we'll kind of do my silly example again. 1, let me start over. 0 or 0 is 0. 0 or 1 equals 1. 1 or 0 equals 1, or 1 or 1 equals 1, or true. Does that kind of make sense? So in other words, the only time it's false is when both sides are false. Okay, so let's do our money game. Okay, so this time I can go to the game if either of those conditions are true. If I have money or I have a ride. So I have no money, and I have no car. Guess what? No game. False. But now I have money, but I have no car. Well, I'm still going to the game. I'm not sure how I would get there, but I have money. I can buy my own. I can buy my own bus ticket. So 1 or 0 is true. See how? Okay, I wrote this wrong. Sorry about that. This should have been a 0 right here. Try to confuse you there. So 0 or 0, 0, 1, 1 or 0, 1 or 1. That's all the combinations. Okay, let's do another one. I also did this row. I skipped a row. This represents that. 1 or 0 is true. So now let's say I have no money, but I have a car. So maybe my friend is going to pay to get me into the game. So, but I get to go because either side is true. And obviously, if I have money or I have a car, I'm going. Okay, so hopefully I didn't make it worse, but that is the OR operator. Now, let's talk about the last one. It's the easy one, not. And it's also different because it's the only one that does not have 2 numbers on each side of it. It's just not 0 and not 1. I want to see if you can, I'm going to take a second and see if you can tell me what you think the values I'm going to write next to those lines are. Hopefully you said, well, not 0 sounds like 1. If it's not false, it's true. And if it's not true, it's false. So you're saying, well, what's the purpose of that? Well, it's like a flip. Whatever the value is, this flips it to the opposite. So if it was 0, it flips it to 1. If it was 1, it flips it to 0. Okay. Having said all that, let's return back to this equation now. So the reason I explained all of that was to explain how this equation works. In the equation sense, we abbreviate these with some symbols. The AND is implied. Whoops. Anytime you see 2 letters side by side. The OR is a plus sign. That's the one I said I wish I used a different symbol because it looks like adding, but in this case, it's when you know you're working with logic, it's not plus, it's Boolean logic OR, and the OR rules apply. And then the not is the line over the letter. So now you can actually read this. Let's read this using Boolean logic. Not X and Y, or X and Y. I'm sorry, X and not Y. I almost didn't see the line there. I'm going to say it again. Not X or Y. I said that wrong again. 3rd time's a charm. Not X and Y, or X and not Y. Okay. So you're maybe still asking yourself, okay, that still doesn't mean, I still don't know where you're going with all this. That's normal. That's to be expected. This S could be read the following. S equals X and Y. Well, let's start with S because it's so much simpler to follow. Okay, let's look at, oh, you know what? I reversed these, and I've probably been confusing you ever since. So I reversed those, made a mistake. Probably making too many mistakes in this video to probably confusing you. So let's erase this. Hopefully that was easy for you to understand that I was just reversing those. But If not, I apologize. Okay, let's look at C. C is very simple because it's very small. Okay, what you're saying here is that if these two, and I like to think of it as two wires carrying a signal. That signal can be either on or off. Does that sound familiar? Binary? So this wire of electricity can either be carrying electricity or it cannot be. It can be powered off. And this one's the same way. Two wires go into an AND. A-N-D. The answer, or what comes out, remember, we have our, and if you hope you wrote this down in your notes, but 0 and 0, 0 and 1, 1 and 0 and 1 and 1. Do you remember the answer to those? 0, 0, 0, 1. That was about 5 minutes ago, 10 minutes ago. Do you remember that? So what that means is if a 0 is going through this wire and a 1 is going through that wire, meaning electricity is going through that wire, what comes out the other end? No electricity, because both must be true. Okay? Now let's look how that works on this row right here. If this is my answer to the carry bit, then do I carry, look at this row right here. This would represent this situation. A 0 goes in and a 1 goes in. Do I carry? No. For two reasons. One is the Boolean, I don't want it to, based on my truth table. And my AND says, no, it won't because both sides must be true. So think about it. The only time I will get a 1 in this row is if both of these are a 1. And that's exactly what I want the situation to happen. See how it says 1 and 1 is a carry? Think about that. The only time you will carry anything up to another digit is when these are both 1s. And allows me to do that. 1 and 1 is 1. 1 and 0 don't carry. 0 and 1 don't carry. 0 and 0 don't carry. All that works. Okay, so that's why that works. Whoops, that's why we use that. Now let me remove all this and let's try to tackle this longer one. Okay, what this is saying is I want the S to be a 1 in either of these two situations, or I should say either or of these situations. If this is true or this is true. Okay, so let's look back and see when those would be true. Again, I've kind of made a mess of this, so I think all I want to do is rewrite. Let's just rewrite this whole thing so it's not so messy anymore. So we have our C and our S. Now, how did we get to this stage right here? Let me remind you how we got to this. You wrote this down by actually adding 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1 is 1, 0. So you told the computer what these values were. Okay, now let's look at that. When do we want, in fact, let me just write out all the different situations again. Okay, when do we want a 1? I just wrote, all these are now two digits representing the C and the S. So this is the C, S, C, S, C, S, C, S. When do we want 1s in the S column? Only this one and this one, or this one and this one. Is that true? Okay, that's true, which means a 0 and a 1. Here's the problem. If we did that same AND, we would now not get the desired result. Do you see why? Because 0 and 1 is false, as we learned earlier. But we want it to be true. So what we do is we just flip in this situation. I'm looking at the first row here, which is this first section here. We just flip the X to a 1. Now that we'll make it true. Now you may ask, well, doesn't that change the problem? Well, we'll look at that. Let's look at the opposite scenario. Let's say we have a 1 goes in, but a 0 goes in. Well, normally we'd get a false, but we want this to be a 1. So we're going to just flip it. And that makes it a 1. And you may be saying, well, that just sounds like you're just playing with, just changing the numbers arbitrarily to make it the way it works. Well, let's try something else. Let's put values in that we do not want. Okay, I mean to be a 1. Okay, so for example, this row right here. I can't click. Okay, whoops. This row right here. Sorry. This row right here, we want to be a false, right? That's this problem right here. Okay, so let's do the problem. If we draw and again, and remember, inside this box is actually transistors doing this math. We'll get to that a little bit later. So if we put 0 and 0, now in this situation, I flip the x. Okay, let's flip the x. What's the answer? It's still 0. See? So in other words, that still gives us the desired result. Now, let's do the other one we didn't want to be a. In this one, we wanted to carry, and it'd be 1, 0. So let's put a 1, 1. Okay, let's flip this. In other words, we're always flipping it, no matter what. And so that becomes a 0. Well, 0 and 1 is false. And look, that's what we wanted. So when we flip it, we get the desire we want for the ones, and we ensure that the other ones are still false. I hope that kind of makes sense. And the reason, so let's think about this. If we have not x or y, not x and y, that means we're going to, in this situation, take the 0, flip it to 1. 1 and 1 is true. Or if we get this situation, we'll flip this one to 0, flip that one to, I'm sorry, we won't flip that one to 0. We'll see it stays x and not y. We flip that one to 1, and it becomes 1. Because that's what we want. Okay, so that's how Boolean logic works. Again, let me simplify this and tell you there's 2 levels of. I'd love for everyone to understand exactly why this works and how this works, but let me give you a little secret. If you can simply memorize some steps of how to do it, you'll still get the right answer on the test. So let me start over really quick and just demonstrate what at minimum you need to be able to do, even if you don't understand what I said. Still try to understand, because that'll further enhance how all this works, but make sure I use the right letters this time. You're still going to do this. You're still going to write down all the different combinations, and you're going to say 0 plus 0, well, that's a 0. 0 plus 1, that's a 1. 1 plus 0, whoops, almost made a mistake. That's also a 1. And a 1 and 1, that's a 1, 0. Okay, now I need an equation. So I have a C and an S. Okay, let's say you didn't really understand all the Boolean logic and the whys and why they're flipping, why they're not flipping. Let's just memorize steps. Go row by row. If you have a 0, don't do anything. Don't do anything. Don't do anything. Ah, I have a 1. And come write the letters. If they're both 1s, don't change them, just write them. If they're 0s, put a line over them. So C is done. S, don't do anything. We have a 1, so we come over here and write x, y, but we have a 0 for the x, so we write a line over it. We combine these with pluses, which are ors. We have another 1, so we write x and y again. The y is a 0 this time, so we need to write a line over the y, and we don't do anything, and you're done with step 2. So again, I'd love for you to understand all of the Boolean logic of the why they're doing the ands and the ors, but if you can simply write an equation based on the truth table, then you'll get the right answer every time. So I'd love for you to understand, but some students just never get to that point, and that's normal every single year. To about a third of the students just say, teach me the steps, teach him what to do, and I don't understand. So instead, in the next video, we'll continue to the circuit and explain how the circuit is the final stage, because this is not actually enough for an engineer to build a machine that adds numbers. That's just great on paper, but he needs to actually see a schematic, a blueprint, a circuit, and that's what we'll be doing in the next video.